equals the square root of x. And first they want the linearization, L of x, for a equals 16. So the first thing I need to do is just write the formula, which is f of a plus f prime of a x minus a. This is the formula. It's carved in stone. I have to write it. Okay, so obviously this piece is x minus 16. Obviously this piece is f of 16. But I have this piece first to find. Oh, I'm sorry. I'm going to change everything into f. I'm sorry. It's denoted by age. Sorry. So f prime of x equals 1 over 2 the square root of x. So this piece will be 1 over 2 the square root of 16 because this is f prime of 16. So I already have all the numbers. I just have to write the linearization, which is a linear function. So L of x equals f of 16 is f in which I replace x by 16, which means the square root of 16 is 4. The next piece, which is plus f prime of a, this is 1 over 2 the square root of 16. The square root of 16 is 4. 2 times 4 is 8. So I have 1 over 8, and then x minus 16. It's done, but I have to solve for the function, meaning I have to distribute and I have to combine like terms. But this is it. This is final. So L of x equals 4 plus 1 over 8x. And when I distribute 1 over 8 to negative 16, I get negative 2. Rearrange everything in the correct order. 1 over 8x, 4 minus 2 is positive 2. And this is fully simplified. And this is the line, the equation of the line, that can confidently approximate the function, the square root of x, in the vicinity of 16. Nowhere else. For any other number, we need another line. But in the vicinity of 16, if you say, evaluate the function at 16.02, I can plug it in, but at the same time, I can approximate it by plugging in 16.02 in this function, in the equation of the line. Is part A okay? Okay, so let's continue then, because there is something else in there. Use linearization to approximate the square root of 17. Okay, so 16 versus 17, they are quite far apart. So I'm not saying the error will be huge. I'm saying 17 is not close enough. For me, it's not close enough to 16. So let's see what happens. So L of 17, they are asking us to use the linearization to approximate the square root of 17. But that is our function. F of x equals the square root of x. So I have 17 divided by 8 plus 2. Back to the graphing calculator. Do not calculate anything by hand and try to avoid entering all sorts. So you know the error, the probability of getting an error or creating an error is much higher. Okay, I see the function is exactly what I have, 1 over 8 multiplied by x plus 2, and I'm going to plug in 17. So when I plug in 17, you may need to highlight and see more than the digits that the column presents. In this case, it's very clear, 4.125. As you know, they will ask us to determine the exact. So this is an approximation. It's not the exact. but the exact will be simply the square root of 17. No problem. In this case, just put in the square root of 17. That's okay. And enter. So the answer, in other words, f of 17, which is the square root of 17, is approximately 4.123105.625. Of course, there is no need to copy all of those. 4 digits at the most will be good enough. And now they're asking us to find the difference between the approximation, which is 4.125, and the actual value of the square root of 17. So I'm going to truncate at 3 digits. So in part D, they want 4.125 minus 4.123, which is a very good approximation, although initially 17, I wouldn't say that 17 is close enough to 16, but apparently the error is very small, which is 0.002. So the approximation was a tiny overestimation of the actual value. Good. Very good. Thank you. Good. Next question. Anything else? Anyone has other questions? Anything else for this test? Shauna, do you have anything? Daisy, do you have anything?
Yeah, actually, can we go over one from 3.9?
Yes, related rates. Related rates.
Yes. Can we do let's see, maybe 10?
Yes. So the page, let's take a look, 3.9, that's fine. So page 364. Okay, and you said number 10?
Yes.
Very good. So let's look at number 10. So, 10 on 364. Very good. And we are given e to 1 minus 3x. And they want us to find dy over dt, given that x is 2, and dx over dt equals negative 1/3. Good. Perfect. Good. So because I see dy over dt here, and I see dx over dt here, that is clearly stating basically that y and x, that's why I'm going to put a dot underneath y and underneath x. It means that they are functions of t. You can say time, t can be anything in this case. Okay, so when I differentiate both sides, I have to keep that in mind, that y is not a simple variable and x is not a simple variable. They are both functions of t. So the left-hand side has to equal dy over dt. The right-hand side, I have to be careful because this is e to a function prime, which is e to the function times the function prime. That's the formula when we differentiate e raised to a function. E raised to a function prime is e to that function times the function prime. times the inner function prime. Good. So then I have e to 1 minus 3x times the inner function prime. 1 prime is 0. Negative 3 is negative 3. But when I get to differentiating x, that's why I put a dot underneath to remind me that this is a function. X is a function. So when I differentiate x, I get dx over dt. I don't have to solve for anything because the problem is asking me to determine dy over dt under the condition that x equals 2 and dx over dt equals negative 1/3. That's all I need to do. So in the past, this was a little bit more difficult. We had to move terms around, divide, multiply, la, la, la. But not in this case, because this is what they want. And I have it solved already. So any questions so far before we plug it in? Okay, so now I will plug it in. So I have e to 1, negative 3 times negative 1/3, this is positive 1, times negative 3 multiplied by dx over dt, which is, oh, I managed to mess it up. I plugged them in differently. Wrongly, not differently, sorry. Okay, sorry about that. So x is 2. X is 2. 1 minus 6 is negative 5. So this is negative 5. So it's e to negative 5. So now, because x is 2, negative 6. 1 minus 6 is negative 5. Now, I'm here. Negative 3, that's correct. But dx over dt is negative 1/3. So this is still e to negative 5. And negative 3 times negative 1/3 is 1. So you can write the answer as 1 over e to the 5th power, because we know the exponential rule. E, or any number to a negative raised to a negative exponent, is 1 over. Of course, you can approximate it if you wanted to, or just leave it alone. So it's not a nice number. It cannot be. It's a very small number, 0.0067. Or just leave it in that format. I'm going to write 0.00673. 738. Good. Is this okay? Do we understand the steps involved here? We understand every step? Anybody would like to say yes or no, so I know? Okay, are there other questions? Okay, so would you like to choose? Also remember that we can, when you go back and review, there are other examples we worked on together in class. Anyone would like to choose another? Is that what you meant, Katie? 15. Okay, very good. Where is 15? Right here. Okay, perfect. So in 15, on the same page, 364, we are given y equals pq. dp over dt is what they want. And when p is 30, q is 250. dq over dt is negative 200. And dy over dt equals negative 5250. Okay. So they want us to find dp over dt. Immediately I'm going to put a dot under p, reminding me that this is a function of t. If you want to say time, that's fine too. I am given dq over dt. Obviously, I put a dot immediately under q because that means that q is a function of t as well. I'm also given dy over dt as being la la la, which means I put immediately a dot under y because even y is a function of t. Now I will use implicit differentiation. So I will differentiate both sides, keeping in mind that all are functions of x. Good. Can anyone help with the left-hand side? What do we have on the left-hand side? Anyone, please?
Just dy over dt.
Thank you. Now on the right-hand side, we have a product of two functions. Which rule applies here? We need to identify the rule because otherwise we will not be able to differentiate.
What?
Very good, the product rule, yes. So the first function prime, dp over dt, times the second one, plus the first function times the second one prime, dq over dt. So it's all done. Now it's all algebra. We're asked to find dp over dt. Well, dp over dt is this, which means I have to move this term to the other side and then divide both sides by q, because I need to solve for dp over dt. So the first step is dy over dt minus p dq over dt equals q times dp over dt. This is what I'm after, which means I have to divide by this. Everything, both sides. So then dp over dt equals this whole thing over q. dy over dt minus p dq over dt. And now I have everything. What everything? So I am given the dy over dt, this piece is negative 5250. I'm given that p is 30. I'm given that q is 250. And I'm given that dq over dt is negative 200. Let's see if we have any questions so far, and then we'll calculate. Any questions on the steps? Any questions on this problem or the steps we followed? Anyone? Okay. So I continue with the calculation as dp over dt equals negative 5250. But here I have negative 30 multiplied by negative 200. So this will be a positive number. And it's 6,000. 3 times 2 and then 3 zeros. And everything divided by 250. You don't have to do anything, just plug it in the graphing calculator with parentheses around the numerator, please. 5250. And then, of course, I forgot to put minus. Insert. Good. And then plus 6,000. Close the parenthesis and divide by 250. And this is the slope, not the equation, just the slope. When I hit enter, is the slope of the tangent line to the graph of function p at the given point and variables and so on and so forth. Okay, nice answer. 3. Good. Anything else? Are there any other topics that we need to review?